And welcome to our project for Francisco Solis's Physics 112 class. For this project, we focused on solenoids, specifically the magnetic field induced by a solenoid. A solenoid is made from a long coil of wire and can be used to generate a nearly uniform magnetic field similar to that of a bar magnet. When current flows through the wire, it creates a circular magnetic field around the wire. So when we wrap the wire into a coil, each wire still produces the magnetic field, except the field lines will merge together and form a larger, stronger magnetic field. Three variables are important to understanding this: current, turn density, and the relative permeability. Solenoid we built, it had 56 turns over 0.044 meters. There is nothing inside the solenoid, so the relative permeability constant of the core, or air in this case, is approximately 1. We are using a 9-volt battery, which produces approximately 0.5 amperes. And then mu naught equals 4 pi times 10 to the negative 7 teslas over amperes times meters. The equations needed to solve for magnetic field include the equation for turn density, the equation for mu, and the equation for magnetic field at the center of the solenoid. We then needed to find turn density, mu, and magnetic field. The turn density is calculated by dividing the number of turns by the length of the coil. So the turn density is 56 turns divided by 0.044 meters, giving a turn density of 1,259.89 turns per meter. Next, mu is calculated by multiplying the relative permeability of the core, K, by mu naught, ultimately producing a mu of 1.256 times 10 to the negative 6. Finally, the magnetic field induced by a solenoid can be calculated. The magnetic field B is the product of mu, the turn density, and the current. This, for the solenoid built at the center of the coils, has a magnetic field of 7.9 times 10 to the negative 4 teslas, or 7.915 Gauss. 4. When looking at the solenoid created, the length of the coil is 0.044 meters with 56 turns, and when a current of 0.5 amps is run through the solenoid with only air in the middle, so a relative permeability of 1.2566 times 10 to the negative 6 teslas over amperes times meters, ultimately producing a magnetic field at the center of the solenoid of 7.915 Gauss.